For more than 50 years, the Boeing 747 ruled the sky. It wasn't just another airplane, it was the airplane. The one with the distinctive hump, the double-deck front, the giant silhouette you could recognize from miles away. And on February 20th, 2023, the world watched what felt like the final chapter. The very last brand new 747 rolled out of the factory, took off, and officially ended one of aviation's greatest eras. At least, that's what we thought. Because just when the world moved on, airlines shifting to quieter, cheaper twin-engine jets, something unexpected happened. The 747 began appearing in places no one predicted. It started flying missions no modern jet could replace, and suddenly, an aircraft we declared finished was back in the spotlight, proving it still had a role the aviation industry desperately needed. This isn't nostalgia. This is economics, global trade, and even Boeing's long-term future colliding in a way almost no one saw coming. Think of it this way. The 747 helped connect the world once, and today, a very different world may need it again. Not for the reasons it was built for, but for reasons its designers cleverly prepared for decades ago. So the real question is, was February 2023 truly the final act or the beginning of a new one? Because the story of the Queen of the Skies isn't just about an airplane. It's about how technology ages, how industries shift, and how a single piece of engineering can find an unexpected second life. And to understand why this comeback is happening, we have to go back to where it all began, with an idea so bold that people thought Boeing was crazy. To understand why the 747 still matters today, you have to go back to the moment it was created, a time when long-distance flying was slow, cramped, and expensive. In the late 1960s, Boeing took on a challenge that felt almost impossible. Build an airplane twice the size of anything in the sky, one that could carry hundreds of people across oceans in a single trip. The result was the 747, which took its first flight in 1969 and entered service in the early 1970s. But what made it truly revolutionary wasn't just its size. It was the engineering thinking behind it. Boeing didn't design the famous hump because it looked cool. The hump existed because the cockpit was moved upstairs. Why? So the entire nose could swing open like a giant door for loading cargo. Even in the 1960s, Boeing quietly prepared for a future where the 747 might need to become a freighter. That's what people mean when they say the aircraft was future-proofed. Inside, the upper deck originally held a small lounge area, but outside, the shape solved two problems at once. It allowed more passenger seats, making long-haul flying affordable, and it created a massive, unobstructed cargo bay, something no other large jet had. The fuselage was built wide enough to fit 2 aisles and large containers. The wings were huge but strong, designed to hold engines that could lift fully loaded aircraft across oceans. And every piece of the airplane, from the landing gear to the floor beams, was engineered for both people and freight. If the 747 were a car, it would be like designing a luxury bus that could instantly transform into a heavy-duty moving truck. This wasn't an accident. Boeing's engineers knew supersonic passenger jets were coming, and they expected the 747 to eventually shift into the cargo world. They didn't know when, they didn't know how, but they designed the airplane ready for that moment. And that quiet design decision, made more than 50 years ago, is one of the biggest reasons the 747 is suddenly back in the spotlight today. By the time the 747 hit its stride, it wasn't just a big airplane. It became a cultural symbol. For millions of travelers, flying on a 747 was the moment you felt like you were going somewhere far, important, or unforgettable. It was the plane families took on their first international trips. It was the plane that carried celebrities, presidents, and entire sports teams. And it was the plane people pointed to at the airport and said, "That one, that's the big one." The 747 didn't just move passengers, it moved emotions. Inside, airlines built lounges, spiral staircases, and first-class cabins that felt closer to luxury hotels than aircraft. If the Airbus A380 is the modern super jumbo, the 747 was the original one that made long-haul travel glamorous. But its legendary status didn't come only from comfort. It came from what the aircraft proved it could do. One of the most famous moments happened in 1991 during a rescue mission known as Operation Solomon. In a single flight, an El Al 747 carried 1,087 Ethiopian Jews to Israel, the most people ever flown on one aircraft. They were crammed onto every inch of floor space. Babies were born mid-flight, and the jet still made it safely. That story alone turned the 747 from a machine into a symbol of hope. It was also the airplane of reunions, bringing soldiers home, connecting distant families, and letting ordinary people cross continents as easily as crossing states. For decades, when someone said they were flying overseas, most people automatically imagined a 747. This emotional connection is important because it explains why the 747's disappearance hit so hard and why its comeback feels so surprising. It didn't just fade from airports, it faded from the memories people had built around it. But the next part of the story is the twist. The same qualities that made the 747 great for passengers are also the reasons airlines began letting it go. For all its glory, the 747 eventually ran into a problem no amount of nostalgia could fix. The world around it changed. By the early 2000s, airlines weren't looking for the biggest airplane anymore. They were looking for the cheapest one to operate. And this is where the Queen of the Skies started losing her throne. A 747 has 4 massive engines, while new long-haul jets like the Boeing 787 and Airbus A350 use only 2. That difference alone is like paying for a car that burns fuel from 4 tanks instead of 2. Even if the engines are efficient, the extra maintenance, spare parts, and checks add up fast. Airlines live on thin profit margins, so every dollar they save matters. At the same time, airports and governments began tightening noise and emissions rules. Modern twin-engine jets were quiet, clean, and far easier to slot into crowded airports. The 747, built decades earlier, simply couldn't match that without expensive upgrades. Passenger habits changed too. Instead of filling 400 to 500 seats on a single giant aircraft, airlines wanted more frequent flights with smaller, newer jets. A 787 or A350 can fly just as far as a 747, but with fewer seats and much less fuel. To an airline CEO, that's the difference between a risky investment and a safe one. And then came the final blow. The industry's shift away from very large aircraft altogether. The Airbus A380, the 747's biggest rival, proved this. Even with its size and comfort, airlines struggled to keep it profitable. If the newest super jumbo couldn't survive, what chance did the older 747 have? Soon, 747s were being retired, stored in deserts, or converted into freighters. Boeing watched orders dry up, and by 2020, it became clear the passenger era of the 747 was ending. On the surface, this looked like the natural fade-out of an aging giant. But behind the scenes, something else was brewing. Something that would give the 747 an unexpected second life in a world that desperately needed its unique abilities. As the aviation world shifted, a new rivalry pushed the 747 into one of its most important chapters. In the early 2000s, Airbus launched a bold challenge, the A380, the largest passenger jet ever built. It wasn't just competition, it was a statement. Airbus wanted to dethrone the 747 as the queen of long-haul travel. Boeing had a choice: either walk away from the super jumbo market entirely, or fight back. At first, Boeing explored an upgraded design called the 747X, a stretched, more efficient version meant to counter the A380. But airlines weren't interested. They didn't want even bigger aircraft. They wanted smarter ones. So Boeing changed strategies. Instead of trying to outsize the A380, Boeing used what it learned from the 747X studies to create something more practical, the 747-8. The 747-8 wasn't a clean-sheet aircraft. It was evolution, not revolution. But it quietly fixed many of the things airlines cared about. It got new engines based on 787 technology, a redesigned wing with modern aerodynamics, a smoother cabin experience with larger windows and better lighting, and improvements that made it faster and more efficient than earlier versions. Still, both giants, the A380 and the 747-8, ran into the same reality. The world didn't need as many super jumbos as it once did. Airlines preferred flexibility over size. The A380 struggled to find buyers, and the 747-8 was produced in low numbers, mostly for cargo operators and a few passenger airlines. But here's where the 747 had a hidden advantage. While the A380 was built almost entirely as a passenger jet, the 747 had something Airbus couldn't match. A proven purpose-ready design for freight, the upper deck cockpit, the massive nose door, the wide fuselage, all of it made the 747 a natural-born cargo machine. And as the world soon discovered, that would change everything. Because the next chapter wasn't about passengers anymore. It was about an unexpected global crisis, and the airplane perfectly engineered to solve it. Just when it seemed like the 747 story was ending, the world ran into a problem no one saw coming, a problem only a handful of aircraft on Earth could solve. When global supply chains collapsed during the pandemic, factories stopped, shipping routes clogged, and countries raced to move medical supplies, protective equipment, and pharmaceuticals as fast as possible. Suddenly, speed wasn't just convenient, it was critical. Ships were too slow, smaller planes were too limited, and many passenger aircraft were grounded. But one airplane was built for exactly this kind of mission, the Boeing 747 freighter. Remember the hump and the raised cockpit? That design allowed the 747's entire nose to open upward like a giant garage door. No other commercial jet can load outsized cargo the same way. Need to move huge engines, machinery parts, humanitarian aid pallets, or even medical equipment too tall or wide for a normal cargo door. The 747 can take it all, and it can move up to 140 metric tons at once, the kind of payload that makes the difference between a slow recovery and a rapid response. Cargo airlines immediately turned back to the Queen of the Skies. UPS, Cargolux, Korean Air, Lufthansa, Atlas Air, Air China Cargo, almost every major long-haul freight operator doubled down on their 747 fleets. Even passenger 747s that had been retired were pulled out of storage and converted into freighters. Today, roughly 300 plus 747 freighters of various versions are still flying, an enormous number for an aircraft most people think is gone. And this wasn't just a pandemic boost. E-commerce giants like Amazon, Alibaba, and DHL triggered a long-term explosion in air cargo demand. People expect packages in days, not weeks, and the 747 is one of the few aircraft that can deliver globally, reliably, and in giant volumes. Even Boeing executives acknowledged it. As one industry leader put it, this airplane remains the backbone of long-range cargo, a statement almost unthinkable just a decade earlier. The 747 didn't just return, it became essential. The heavy lifter that kept the modern economy running when everything else failed. But that raises a new question. If the world still needs the Queen of the Skies, could she evolve again? For years, the GE9X program felt like a giant stuck in wet cement. Too big to fail, but honestly, just too slow to actually move. But then, almost out of nowhere, something changed. And it happened because Boeing reached a moment where doing nothing became more expensive than, fixing everything. By 2023 to 2024, airlines were getting restless. They were placing orders for the 777X, but only on paper. Many of those orders were soft, meaning they could be canceled or swapped if the aircraft didn't arrive soon enough. Airlines don't like uncertainty. They plan fleets like chessboards, years ahead. A delayed flagship model can throw off entire network strategies. Boeing understood that the 777X had one chance to prove it wasn't another 787-style delay saga. And that meant the GE9X had to stop being just the world's biggest engine and start being the world's most reliable engine. So GE made a decisive move. They shifted from trying to perfect new materials to locking down the ones that already worked. They stopped experimenting and started stabilizing. Think of it like a chef who keeps trying exotic ingredients, but eventually realizes customers just want the perfect version of a classic dish. The GE9X didn't need more innovation. It needed consistency. That focus changed everything. Test engines that once struggled to meet endurance limits suddenly began passing cycles with margin to spare. Components that used to fail early were redesigned with simpler, sturdier solutions. And the fuel burn, the GE9X's big selling point, finally started matching the aggressive targets Boeing promised airlines years earlier. By 2024, early 777-9 test flights showed something Boeing desperately needed: confidence. Not perfection, not miracles. Just the sense that the entire aircraft engine package was finally approaching the finish line together. And that shift set the stage for the next chapter. Why Boeing ultimately stuck with the GE9X, even when walking away seemed easier. By the time Boeing reached the crossroads, it had two choices: cut loose from GE and redesign the 777X around a new engine, which would add years of delay, or double down on the GE9X and push it across the finish line. On paper, the first option might sound tempting. Reset the program, start fresh, avoid inheriting GE's problems. But in reality, that path would have been like trying to rebuild a skyscraper from the ground up after already finishing the 60th floor. Here's why Boeing stayed. First, the 777X was engine optimized to its core. Every major part of the aircraft, its wingspan, weight limits, aerodynamics, fuel systems, was built around the GE9X's enormous size and specific performance numbers. Switching engines would mean redesigning the plane, retesting it, recertifying it, and basically restarting the clock. Airlines would have walked away. Second, no other engine maker was ready. Rolls-Royce didn't have a competing engine in the right size category. Pratt & Whitney wasn't in the big wide-body game. GE was the only player capable of producing something powerful enough and fuel-efficient enough for a jet this large. Switching wasn't just painful, it was impossible. Third, GE had already solved the hard problems. By 2024, GE9X test data showed clear improvement, lower vibration, better durability, more stable thermal performance, and fuel burn that finally matched, and in some cases beat, the targets Boeing promised airlines. The turbulence of the early years was fading. The engine was maturing. Boeing had already invested billions. GE had invested billions more. To walk away now would have been like abandoning a marathon at mile 24. Fourth, airlines wanted stability, not drama. Customers like Emirates and Qatar didn't want Boeing to reinvent the program. They wanted the airplane they were promised, as soon as possible. And by staying with GE, Boeing sent the message airlines needed to hear. The finish line is real. We're getting there. Fifth, the GE9X would eventually give Boeing a long-term advantage. Once mature, the GE9X could become the most fuel-efficient engine in its class, a long-term revenue machine from maintenance contracts, and a technological foundation for future wide-body engines. Boeing wasn't just betting on fixing a problem, it was betting on decades of payoff. In the end, staying with GE wasn't the risky choice. Walking away was, and now the story moves toward its climax. what the GE9X means for aviation's future, and whether it can carry the 777X into a new era. With the GE9X finally stabilizing, the spotlight shifted to what this engine and the 777X program could deliver for airlines and aviation as a whole. The stakes are massive. These planes are meant to fly long-haul routes that define international travel networks. Every percentage of fuel efficiency or reliability translates directly into millions of dollars saved and reduced carbon emissions. First, fuel efficiency that changes the game. The GE9X was designed to burn roughly 10 to 12% less fuel than the engines on the 777-300ER, its predecessor. Over a single long-haul flight, this difference can save tens of thousands of dollars for an airline, and over a year, potentially millions. Compare it to a hybrid car replacing an old gas guzzler, but on a scale of a building-sized machine flying 8,000 nautical miles non-stop. Second, advanced materials and aerodynamics. The engine's fan blades use ceramic matrix composites, which are lighter and heat-resistant. Combined with a redesigned high bypass ratio, these improvements not only reduce fuel consumption, but also lower maintenance costs. Boeing can now offer airlines fewer checks, longer life cycles, and smoother operations, all major selling points in a competitive market. Third, unlocking new routes and operational flexibility. With the GE9X's efficiency and thrust, the 777X can serve ultra-long-haul routes that were previously uneconomical. Cities once considered too far for direct flights now become feasible. Airlines can consolidate flights, save crew costs, and improve aircraft utilization, a ripple effect that reshapes global travel networks. Fourth, environmental impact. A quieter, more fuel-efficient engine is critical. With governments imposing stricter emissions standards, the GE9X allows Boeing and airlines to fly greener. It's not just about economics, it's about surviving in a world where environmental compliance increasingly drives operational decisions. Fifth, lessons for future engines. The GE9X's journey sets a precedent. Aerospace engineers now have a blueprint for balancing cutting-edge materials with reliability. Future engines can push boundaries without repeating early-stage failures. The 777X program becomes a case study in patience, iterative design, and the payoff of long-term collaboration between manufacturer and supplier. The GE9X isn't just an engine, it's a symbol of resilience in aviation engineering. Its story proves that innovation can survive early setbacks, and that bold, patient investments can reshape the skies for decades. This leads us naturally to the final act, the 777X and GE9X together, redefining what modern long-haul flight looks like and what passengers and airlines can expect from the next generation of wide bodies. The saga of the GE9X and the 777X is more than just an engineering story. It's a lesson in persistence, risk, and vision. From early setbacks and design challenges to stabilizing a game-changing engine, Boeing and GE have shown that bold innovation often comes with turbulence, but the payoff can redefine an entire industry. Airlines and passengers will soon experience the results: longer non-stop routes, lower fuel costs, quieter cabins, and a more sustainable footprint. For Boeing, the GE9X isn't just an engine. It's a foundation for the future of wide-body aviation. For the world, it's a reminder that technology, patience, and collaboration can overcome seemingly insurmountable obstacles. So what can we take away? Every obstacle, whether technical, economic, or regulatory, can be a stepping stone if addressed strategically. The skies are about to get quieter, more efficient, and more connected, thanks to lessons learned from the GE9X's journey. If you found this story fascinating, hit like, subscribe, and leave a comment. Which part of the GE9X journey surprised you most? And stay tuned. Our next video will explore the 777X's real-world flights and how it's transforming the way we think about long-haul travel. The GE9X has proved one thing: great innovation can endure, evolve, and take flight, no matter how rough the start.